Alright, so we're continuing section 4.4, and what we're going to be talking about is matrix multiplication. So again, this is still section 4.4, matrix multiplication. And in class, I kind of suggested what the naive way to do it would be to take two matrices which are the same size and try to multiply them component-wise. But that's not going to be it. It's going to be a little bit different. Now, the most basic form of matrix multiplication is taking a row matrix times a column matrix. So that's what we will study first. And for this just two notes about this. The two matrices, if we have a row and a column, have to have the same number of entries. And what this really implies is that the row matrix is a 1 by n matrix row, and the column is n by 1. Okay. And the second thing is that the result is, the book writes it as a 1 by 1 matrix, but for me, a 1 by 1 matrix is just has one entry, so it's just a real number. So I'm not even going to bother writing it as a 1 by 1 matrix, because that would look like, that. It's pretty silly. Why not just write that as the number 3? Okay. So how does this work out? Let's do it by example. Let me take the matrix 1, 2, 3 and multiply that against the matrix, let's say -1, 0, 1. What we're going to do is we are going to multiply the first entry of the row matrix of, excuse me, I've got this backwards. It's going to be a row times a column. So what we're going to do is take the first, let me rewrite this as, say, 1, 2, 3 times -1, 0, 1. Okay, that's better. So this is 1 by 3 being multiplied against 3 by 1. Okay, so now what we're going to do is we're going to take the first entry of the row and the first entry of the column and multiply those together. We're also going to take the second entry of the row and column and multiply those together, and the second entry, or the third entry of the row and column, and multiply those together. So what we get from that is we have 1 times -1, that's from the first entries, 2 times 0, that's from the second entries, and 3 times 1. And then we take that and we add them together. So the result is -1 plus 0 plus 3, which is -2. So this is -2. That's our final answer. But again, where does it come from? These two numbers here come from the first two components. These two numbers here come from the second two components. And these two numbers here come from the third two components. Okay. Let's do one more example of this because I feel like this is fairly straightforward. This time let's do a 1 by 4 times a 4 by 1. And let's say it's 2, 0, 1, -1. And let's multiply that by 3, 5, -4, 2. Okay. So these are there are 1, 2, 3, 4 components in each of these. So this is 1 by 4, and this is 4 by 1. So what we get is the first component times the first component, 2 times 3, the first entry times the first entry, the second entry times the second entry, so plus 0 times 5, the third entry times the third entry, so that's plus 1 times negative 4, and then the fourth entry times the fourth entry, so that's minus 1 times 2. And what we get here is 6 plus 0, 1 times minus 4 is negative 4, negative 1 times 2 is negative 2, 6 plus 0 is 6, minus 4 minus 2 gives us 0. That's a little weird because we have two matrices which are non-zero, but whose product is 0, and that's just one of the weird things that happens with matrices. Now let's look at the general matrix product. And this is the way it's going to work out. We're going to have to take an m by n matrix, and we can multiply this by an n by p matrix. So the number here and the number here have to agree, and the result is an m by p matrix. So m by n times n by p gives me m by p. But what this really means for these two numbers here to be the same is saying that the number of columns of the first matrix has to be equal to the number of rows of the second matrix. So that's what happens. And then the result has the same number of rows as the first matrix and the same number of columns as the second matrix. And how do we do this? Well, let's suppose I'm just going to draw some sort of arbitrary looking matrices. And let's say that this one has m rows and n columns, and this one has n rows and p columns. And what we're going to do is let's take a row here. Let's say that this row is 1, 4, 7, 2, whatever. So I'm assuming that n is equal to 4. And let's take a column here. Let's say it's 0, negative 1, 3, 5. And to multiply this matrix, we will take each row and multiply it by each column. And that will give us an entry in our m by p matrix. Now, which one? Well, let's suppose that this is, I don't know, row 3, and let's suppose that this is column 4. Then the result here, 1 times 0, plus 4 times minus 1, plus 7 times 3, plus 2 times 5, that's negative 4 plus 21, plus 10, it's supposed to be a 4 and not a 9. So that's negative, that's 17 plus 10, so that's 27. The number 27 then appears in the third row in the fourth column. So it's the 3, 4 entry. So what this says is the row, let's call it L times column K gives the LK entry of the product. So row 3 times column 4 gives us the 3, 4 entry of the product. Now let's do some explicit examples here. The first one I'm going to do is, let's do, say, let's do a 2 by 3 times a 3 by 2, so the result will be a 2 by 2 matrix. And let's take something like, I don't know, I'm just going to make the numbers kind of small to make things faster to do. Let's say it's 1, 0, negative 1, 2, 1, 0. So that's 2 rows and 3 columns. I'm going to multiply this by a 3 by 2 guy. And what I'll put here is, again, let me just put some small numbers. 3, 1, 0, negative 1, negative 1, 2. Whatever. Okay. The result is going to be a 2 by 2 matrix, but let me draw it kind of large here. how do I find the result? Well, I'm going to multiply each row of the first matrix by each column of the second matrix. So here's our first row of the first matrix. Here is the second row of the first matrix. Here is the first column of the second matrix. And here is the second column of the second matrix. And so what do we get? What we get is the first entry is the first matrix times the first row times the first column. So I get 1 times 3 plus 0 times 0 minus 1 times negative 1. So this times this gives me this. Let me highlight that just to see what that looks like. That's yellow and purple, which gives me sort of an orangey color. Okay, maybe that makes sense. The next one is going to be the first row times the second column. So it's 1 times 1. It's going to be 1 times 1 plus 0 times negative 1 minus 1 times 2. Okay. And again, let me just sort of suggest where this is coming from. That's the first row, but it's the second column, which gives us this, well, it's a bluey, greeny color. Okay, more blue, I guess. Okay, this third row, excuse me, this entry right here, the second row in the first column is the second row times the first column. So we get 2 times 3 plus 1 times 0. Plus 0 times negative 1. Okay. And this, what is that? Highlighter-wise, that is the first row, or the second row, times the first column, and that gives us this lovely sort of gray color. Nice. And the last one is going to be row 2 times column 2, so I get 2 times 1, and that's going to be plus 1 times negative 1, plus 0 times 2. Again, just to suggest where this is coming from, this is the second row times the second column, which gives us that sort of blue-green. So this orange guy came from yellow times purple. This bluish guy came from yellow times blue. This gray guy came from green times purple. And this greener guy came from green times blue. Fantastic. So what then is the result of this? The result here is that we get, this is 3 plus 0 plus 1. So that's 4. This is 1 plus 0 minus 2. That's minus 1. This is 6 plus 0 plus 0. So that's 6. And this is 2 minus 1 plus 0. So that's 1. So this is our result. It's a 2 by 2 matrix, which is what we expected. Okay, that is the answer right here. I don't think I have time in this video to do another one, but what I tend to do when I do matrix multiplication is I like to sort of, to figure out what the first row of entries is going to be. I drag my finger across the top, and I drag my finger down each of the columns. So across the top row and the first column gives me this. Across the first column and the second row gives me this spot. Those aren't zeros, those are circles. Across the first row and the third column will give me this. Then I go to the second row. The second row down the first column gives me this. The second row down the second column gives me this. The second row down the third column gives me this, etc. And I kind of just use that to keep track of what I am doing.